Hey everyone, Mr. Fransky here. Today we're going to look at a little bit more about finding type 1 and type 2 errors using Poisson distribution. And in this case, we have Mr. Rops on Snapchat. So the number of likes on Mr. Rops' popular Snapchat account is 1.5 per minute. His students know that he's really popular on Snapchat, and they believe that it's actually higher than 1.5 per minute. So we're going to assume the number of likes follows a Poisson distribution. So we're looking at a Poisson distribution. Maybe have a letter here. Let's do L for likes, is Poisson with an average of 1.5 likes per minute. And what we're going to do here is we're going to look at 30 minutes, and we're going to test the claim at the 5% level. So if we're actually doing 30 minutes, so let's call that L30 maybe, is going to be Poisson at 1.5 times 30. 30 minutes, 1.5 likes per minute, that's 45 likes is what we expect over the course of 30 minutes. Let me make that 30 a little bit better. There we go. Okay, so I believe it's Poisson, and we're going to test to see whether it's actually 45 or whether it's bigger, because they think that it is higher specifically. So for part A, for our state the number of likes in the tested time interval, well, we expect 1.5 times 30, which is 45 likes in 30 minutes. Okay. Then for part B, they want us to state appropriate hypothesis. So the null hypothesis always is that we are equal to some value. So that would be that we have an average of 45 likes total. I'm going to do that with a lambda. So lambda equals 45 likes in 30 minutes. And the students believe that's not true. So the alternative hypothesis is that lambda specifically is higher. So it's greater than 45 likes in 30 minutes. Okay, so we have our null alternative hypotheses. Now we're going to find a critical region. So obviously we're going to need more than 45 likes, right? And if we think about this in terms of probabilities, right? The probability at the very beginning is going to be very low, then it's going to get a little bit higher, and then it's going to start to come back down, right? And there's some value where if we get enough, so the highest one will probably be around 45, right? The highest probability. And then at some point, though, if we cut this off, we're testing this at the 5% level. So to the right of that value, I want less than 5%. Less than 5% of my data. And of course, that means on the left-hand side, there's more than 95. More than 95. So we can do this either way. I really like to do the 1 minus CDF to find the less than 5%. I think it makes a little bit more sense. So that's how I'm going to do it today. But of course, you could just do over here, just Poisson CDF. CDF up to X, so you do 45 and X. Over on the right side, I'm going to do 1 minus Poisson CDF at 45 and X. Right? Because then I know I'm looking for the 5% level. If you do the left side, you're going to be looking for something that is greater than 95% for the first time. But you can do it either way. I'm going to do it with the 1 minus Poisson CDF, looking for less than 5%. So what I'm going to do, because I don't know what that value is, right? There's some X here, there's some X plus 1 here. I'm going to do a Y equals. So I'm going to do 1 minus, go to my distributions, second distor, Poisson CDF, here it is. And I'm going to do 45 likes in 30 minutes, and then I'm just going to say X because I don't know what that value is that I want. And we're going to look at our table. So once again, our table is probably starting at 1, right? Not helpful, because right now we're doing 1 minus Poisson CDF of like 0. Obviously, that's going to be 100%. It's really close to 100%. I want to start this table. Let's start, I don't know, where we kind of expect the highest value. So let's start at 45. And then we'll just be able to scroll and see how many we need. I'm guessing it's going to be somewhere in the 50s or maybe the 60s, but we'll see what happens here. So we're starting at 45 now. So we see we have like a 46 or a 46% chance of being less than or equal to 45. That would actually be 44 because we're doing 1 minus CDF. So if we go, we're looking for the first value that's what? Under 5%, right? Well, it looks like it's right there. So the first value, I'm going to scroll this just a little bit more so we can get a nice screenshot. Whoops, it always happens. All right, so I'm going to get a nice screenshot here with that value highlighted. So let me get a screenshot so I can pull it over and put our little table right here. Crop that. So again, we have to be a little bit careful about what exactly this value means. So the shortcut, right, and especially when we get into type 1 error in part D, is just find the first value that's under 5%. And that's kind of the easy way to think about it. But I have to think about what this means, right? So at 56, that is the x value that's put into this equation. So 1 minus Poisson CDF of of 56. So when x is equal to 56, I'm doing x equals there, that'd be better. X equals, I can't write, 56, there we go, was less than 0.05. So what does that mean? That means that if x is greater than or equal to 57, then I would reject the null hypothesis, right? Reject the null hypothesis, because then the students would be right. Mr. Rops thinks it's 45, the students think it's more. And so if we're over or equal to 57, that's my critical region. And let's go through again kind of how we got that number. So it was all these values were 1 minus Poisson CDF of the x value, right? So if we do 1 minus Poisson CDF at x equals 56, that is all the values to the left here. So this is 56 right here. So up to and including 56, it would be like a 95.3% or something, right? To the right side, we have 0.04726, right? So that's less than 5%. So that means that's when I would reject if we have 57 or more likes in those 30 minutes. So now they want us to ask about the probability of a type 1 or type 2 error. So type 1 error, that's the easy one. We just have to look at the probability of being in our critical region, right? So for I, so remember a type 1 error. Type 1 error is when we reject kind of by accident, right? But shouldn't have. So what that means is that the lambda is indeed 45, but we were in our critical region. Well, the probability of that happening is exactly what we're looking at here. You just have to pick the first value that's under your alpha value, right? So in this case, the probability of a type 1 error, is going to be 0.04726. Wonderful. All right, and now for 2, they want to know a type 2 error given the actual number of likes is 1.62, and they have to give you some correct average value or some correct population parameter, whatever that might be. So remember, a type 2 error is when we do not reject, but should have. So in our test case, right, when would we not have rejected? Well, that means we must have gotten 56 or less likes, right? We must have gotten 56 or less likes. So do not reject, let's highlight here a little bit. So do not reject, what that means is that, back to my pen. What that means is we must have gotten 56 or less likes because we didn't reject our null hypothesis in our 30 minutes. And so now what we have to do is find what is that probability. What is the probability that we got less than or equal to 56 likes given, I dropped my notation about L, but it's okay. So what is the probability that x is less than or equal to 56 given that the average is actually, we have to think about this now, it's 1.62 times 30. Check that out. So 1.62 times 30 gives us 48.6. So when we actually expect 48.6 likes. All right. So now we just do that with Poisson CDF. So I'm going to do second distribution. We're going to do Poisson, distribution. There we go. Get me out of here. So Poisson CDF, there we go. And our average is 48.6. And we got up to and including 56. That's why we're using CDF. Okay, so we know that we were not in our critical region, right? We were somewhere over here. We don't know exactly where, but it must have been 56 or less because in a type 2 error situation, we did not reject the null hypothesis, so we can't be in our critical region. But we should have rejected because the average is actually higher than the 45 that we thought it was going to be. So Poisson CDF, 48.6 is our average, and we want less than or equal to 56 likes, and that probability is 0.870, right? Now, you might look at that and say, wow, that's a really big probability of a type 2 error, and you'd be right. But let's look at kind of what's going on, right? The students said that they think it's more likes. They think it's more likes. There's a higher number of likes per minute for Mr. Rops. He said it was 1.5, but if the actual value is 1.62, that's such a small increase, right? And so it's not even really that useful, right? Like if the average increased to like 3 likes per minute, if the average increased to 3 likes per minute, there's a very small chance that you would have a type 2 error, because the fact, like if you're expecting, let's do 3 times 30, 3 times 30 is 90, right? If you're expecting 90, the odds that you get less than 56 all of a sudden go down quite a bit. But because we only increased a little bit to 1.62, this value barely increased. Like it's still expected that we should have less than 56, right? So even though the students are correct that the average is higher, it's not high enough to reduce that probability of a type 2 error a lot, right? Which is why that probability is so high. But hopefully the calculation here wasn't too tough, and you were able to follow along with how to find type 1 and type 2 error for a Poisson distribution.